Hey guys, how you doing? So we're going to go over a specific problem right here about kind of power type 1 and type 2 errors. This is the review on the review section, 9.5. This is page 615 actually in your book if you're following along right here. All right, and this is like a really thorough problem all about type 1, type 2 errors and power. Okay, let's take a look here. Notice right here, if this has this play button right here, you can also just get the book videos from my link in Google Classroom. Okay, a drug company has developed a new vaccine for preventing the flu. The company claims that fewer than 5% of adults who use its vaccine will get the flu. To test the claim, researchers give the vaccine to a random sample of 1,000 adults. State appropriate hypotheses for testing the company's claim. Be sure to define your parameter. Okay. So this is part A. We're talking about proportion right here. So the null is that's a statement of equality. The true proportion equals 0.05. The alternative is that the true proportion P is less than 0.05. And then define the parameter where P equals the true proportion of adults who use this new vaccine and get the flu. Okay, so that's the proportion of adults who use this vaccine and still get the flu without, and I just said right here with alpha equals 0.05. Now they didn't define that, so I guess you didn't really have to say that since it's not a four-step process. But in a four-step process, you would just say that the alpha is 0.05. Okay. So remember that when we're doing the rest of this problem, we want to right here, of course, we want to find evidence for the alternative because, of course, any company wants their flu vaccine to have a smaller amount of proportion of people who actually get the flu. All right, so let's look at part B. Describe a type 1 and type 2 error in the setting. Give the consequence of each. Okay, no problem. So a type 1 error, remember we said in class, type 1 error, someone that's just like really arrogant. It's always trying to give evidence for the alternative when it's an error right here, so it would be the null is true. Type 2 error is that you fail to give evidence for the alternative when the alternative is true. So type 2 error is someone that's like really overly careful. Type 1 error is someone that's really overly arrogant. All right, so type 1 error. Right here, so we're giving evidence for the alternative when the null is actually true. So researchers find convincing evidence that P equals the true proportion of adults who use this vaccine and get the flu is less than 0.05, when in reality the null is true. It is P does equal 0.05. So here it is right here. Researchers find, sorry about the bad handwriting. Researchers find convincing evidence that P equals the true proportion of adults who use this vaccine and get the flu is less than 0.05. And when in reality, it was the null that's true. It is 0.05. All right, so let's think about this. What could be a consequence of this? The company is, if the researchers say this, the company will go by what the researchers say. So the company is going to make the claim that their vaccine has only less than 5% of people who actually end up getting the flu, but it's actually 0.05. So the company's like lying, basically. That's a pretty serious thing. So claiming that the consequence is claiming the vaccine is more effective. They're going to say that that's less than 5% of people get the flu. So it's claiming that it's more effective than what it really is. This could be like lawsuits, big, This could be a really serious thing. That's a type 1 error. Okay? Type 2 error. Just remember about type 2 errors. This is when it's too careful. That's right here. You don't give evidence for the alternative when the alternative is true, is actually going to be true. All right, so let's take a look right here. So right here, in this case right here, we fail to find convincing evidence that P, the true proportion of adults who take the vaccine and get the flu, is less than 0.05, when in reality, the true proportion is less than 0.05. Okay, so when in reality, P does actually equal 0.0, I'm sorry, I said that wrong. When in reality, P is actually less than 0.05. Okay. So if you actually just want to write that out, when in reality P is actually less than 0.05. Looks a little better when you read it like this. Okay, that's good. Okay, we already defined that P, the true proportion of adults who take the vaccine. So when in reality, P actually is less than 0.05. All right, so what's the consequence here? So in this case, they're actually doing the good thing right here. It says the true proportion of adults who take the vaccine and got the flu, it is less than 0.05 right here. But actually the P actually is less than 0.05, but they fail to find convincing evidence right here. So they're going to end up thinking that they didn't do a good job with this vaccine when they really did. So not believing that the vaccine is effective when it actually is. So they're going to have to redo the work. And so that means it's a loss of money for the company. Okay. So it's going to be loss of money. They're going to have to redo everything. All right. So that's the consequence right there. Okay. So if you look at this, type 1 is actually much more serious. Lawsuits could be billions and billions of dollars. People thinking that's good. The type 2 error, they're just going to have to redo something about the vaccine. That's a loss of some money, but not as serious as what lawsuits could be. Okay, part C. Would you recommend a significance level of 0.01, 0.05, 0.10 for this test? Well, we said that right here, the type 1 error is much more serious, right? Because that could lead to lawsuits and everything. So how could I make it so it's less likely for a type 1 error? Remember, alpha is the probability of a type 1 error. Okay? So if I lower that alpha, then it's going to be less likely for a type 1 error. So since a type 1 error is much more serious, and I just said that alpha equals the probability of a type 1 error, so I'd recommend alpha equals 0.01, right? They gave us an option of 0.01, 0.05, or 0.10. I'd recommend alpha equals 0.01 to minimize the chance of making a type 1 error. So making a type 1 error, okay? All right, so if you lower alpha right here, if you think about that, if you lower alpha, it's going to be much harder to reject the null, find evidence for the alternative, so it's much less chance of making that type 1 error, okay? D, the power of the test to detect the fact that only 3% of adults who use the vaccine would develop flu using alpha equals 0.05 is 0.9437. Interpret this value. Okay, so what this is saying right here, this actually, I'm going to just copy these two separately and just put them on a different part right here. All right, here we go, good. Okay. The power of this test to detect the fact that only 3% of adults who use the vaccine would develop using the flu using alpha equals 0.05 is 0.9437. Interpret this value. So here's how we interpret power. Okay. And what right here is that P actually equals 0.03 right here. So what we're going to say is right here for the power, it's the probability that you'll find convincing evidence for the alternative, just to remind you. It's probability find convincing evidence for the alternative, given that the alternative, some value of the alternative is actually true. So here's how we started out. We're going to say, given that the true proportion, and actually, to be honest with you, I think I'm just going to go, just to make this easier right here, I'm going to type this right here. So we're going to say, given that the true proportion of adults who take this vaccine, okay, so we're saying right here, just to remind you right here, this was the parameter, remember, was that the true proportion of adults who get the flu after taking this vaccine and get the flu is 0.03. And then now we're going to go to the probability right here, finding convincing evidence for the alternative. So we're going to say there is a 0.9437. Okay, so we're going to say there's a 0.9437 probability of finding convincing evidence of the alternative. And the alternative, of course, right here is just going to be H sub A. Okay, which, and you can just say what it actually is, that of course that P is less than 0.05. Okay. And that's it right there. Okay, so given that the true proportion of adults who take this vaccine and get the flu is 0.03, so that's the alternative is true part. That's given that the alternative right here is true. There's a 0.9437 probability of finding convincing evidence for that alternative, which is that P is less than 0.05. Okay. All right. And yeah, if you want to, you can put that little part in parentheses. Doesn't matter though. Okay. That's part D. Explain 2 ways that you can increase the power of the test from part D. Okay, let's see here. How can I increase the power? Good question. Okay, so to increase the power right here, we can do 3 things. And part D right here. So remember, there's 3 ways that we can increase the power. We can up the n value right here. Now, right here, we can make it, to increase the power, we can make it easier to find evidence for the alternatives. So that means that right here, we would lower the, we would up the alpha value, right? We would up the alpha value. That means it's easier to find convincing evidence for the alternative, or we could make a larger distance from the null to whatever the true proportion or the true parameter is. Now, we can't really do this third one right here because it already gave us that the true proportion is 0.03. We can't change that, right? But we could change the other 2. So we're going to say right here, I'm going to say to increase the power, we can have a larger sample size, or we could, right here, increase the alpha, the significance level. So it is easier to reject the null and find convincing evidence for the alternative. Okay, and that's all you have to say right there. So to increase the, sorry about the misspelling right there. So to increase the power, we can have a larger sample size, or we could increase the significance level so it's easier to reject the null and find convincing evidence for the alternative. Okay, and that's it right here. The book actually didn't even have this little, so it just said to increase the power, we can have a larger sample size, or we could increase the significance level. Okay, you don't even need this last part right here. Actually, if I'm looking at the book's answer right here. All right, so you could just say this right here. Okay, but that's the explanation why, right? If we bring that up, it's easier to reject the null, find evidence for the alternative. Okay, all right, that is it. Hope you understood, guys.